All right, so the link state advertisements, we saw 5 main link state advertisements. The one which is very important is this first 5. In that, router LSA comes from every router, network LSA comes from DR router, summary LSA comes from ABR, both summary LSA. Third one, type 3 LSA is called a summary LSA. Type 4 is autonomous system summary LSA. You simply put one more word, autonomous system summary LSA. This is type 4. Autonomous system summary LSA. So, and then type 5, autonomous system external LSA. I'll quickly ask you some question to check whether you understood this very well, and then we'll move on to the next level. Are you ready? Now, what is that type 4 LSA carry? ASBR is router ID. You should say that clearly, router ID of ASBR. And it is originated from ABR or ASBR? Very good. What is type 5 carries? What does it carry? Correct. Correct. Are they summarized by default? Okay. Yes. The type 5 and type 3, they are carrying updates. Type 3 carries the updates of one area to area 0 and vice versa. Every area should be connected to area 0. We all know that. That is why I said it carries updates of one area to area 0 and vice versa. That is also not summarized. So we will be learning 2 types of summarization. One is ABR summarization, another one is ASBR summarization. Before that, we need to learn 2 more things. One is that virtual link. Have you done virtual link lab? Did I show you virtual link lab? Let us do that first. What is a virtual link? Virtual link is to make an area which is in the middle of two other areas to be a link. You see here, for example, there are 2 areas in yellow color. In the middle, you have a blue area. Now, your aim is to merge the yellow. For that, you want to convert or you want to make area 1 to be seen as a wire, virtual link, so that this yellow and that yellow will get merged through that virtual link. See, if you don't have this virtual link, they are 2 separate areas. Area 0 will not be seen as one area 0. It will be like two different autonomous systems. See, in OSPF, you should have only one area 0. You cannot have more than one. You should have only one area 0. So if you have two separate, if you don't have virtual link, it will be like this is one autonomous system, this is another autonomous system. It will break. Please go ahead. Balagaru, what is your question? Hmm. 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 Good question. You see, if it is there, you can do this. It's not a good design in first place. It's a very poor design. Splitting one area in two different locations is a very bad design. See, we call it as one area because we want it to be in one group. Why then it is scattered here and there, which means there is no proper planning. But if it is there, yes, you can use the virtual link to merge. So this is one of the use case. But if you would have learned virtual link earlier, they would have not shown this type of example. They would have said this as area, let's say 10. This is another use case. You see, every area should be connected to backbone area, but this area 10 is not connected to backbone. It is connected to area 1. Only area 0 is the backbone. No other area can be a backbone. Now, how do you connect this area 10 to backbone? So we put one virtual link so that we can form neighborship with area 0 so that area 10 can give the routes to area 0 and area 0 will give the routes to area 1, area 2, etc. This is the widely seen use case. But in this presentation, they have given something which not many people think about. But area 0 is, for some reason, split into 2. In real world, very bad design this one. You know, area 0 determines the autonomous system. In real world, if you have two area 0, then it is two separate autonomous system. But how can an organization have two separate autonomous systems? So it's a mistake they have done somehow. They made this mistake, so they want to merge for time being, temporarily, just a temporary solution. They want to merge this area 0 and this area 0. So using this two router ID of A and B, using the router ID of A and B, you can merge. See, this is not just A and B router. You may have router C, D, E, many routers in the middle. But you're going to negotiate this tunnel between A and B. A and B are reachable already because they are in single area. Type 1, type 2 LSAs are advertising the link state info. As a result, A can ping B. Using this reachability, You want to form a link virtually. You want to form an association between A and B so that with the association you can agree to encapsulate then send. Actually, area 0 update will go and it will get covered with area 1 ID. Using area 1 ID, it will go up to here. Again, it will uncover and area 0 will be revealed and it will be delivered. That is what tunnel means, encapsulation. You see here the configuration, area 1. Actually, you are merging to area 0. But in the command, you should not mention area 0. Why? You are on router A, which is already in area 0. And you want area 1 to appear like a link. So you have to mention that only, not area 0. Which one you want it to be appearing as a area 1? Which one you want to, which area you want to pretend appear like area 1? Sorry, like virtual link. Area 1. So you have to say area 1 virtual link and then router B's router ID. Please pay attention. You may have physical interface address 17.1. Don't give that here. That here. You should give only the router ID of this router. Why? You want to negotiate with area 0, not with area 1 interface. You want to form a connection between area 0 to area 0. You want to form connection between area 0 to area 0. So use area 1 keyword. Use the area which is there in the middle and put the keyword virtual link and then router B's address. Likewise, go to router B, virtual link, router A's address. Yeah. So this is how we configure virtual link. So what I'll tell you, Bala, you can try this if you want, or make this as area 10. And try. Both are same. See, in both you need virtual link. In this situation also, in this scenario as well, we need virtual link. Why I need virtual link? Because area 10 is not connected to backbone. Area Z, 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 0. Area 0. Good. Area 0. Right. So try this and let me know. I will also do this lab in some time, but you will also try later. Now, in your routing table, if you see O, what does that mean? Those routes are learned from same area. If you see OIA, what does that mean? Coming from other area. IA means inter area. Now, what LSA brings other area routes? What LSA brings other area route? What? Hemandi, I asked you what LSA brings. I did not ask you which router. Hemandi, ooh, you're confusing. Somebody or network. Type 3 LSA. But Huh. Really? So what brings the other area routes into an area? It is, yes, LSA type. Somebody LSA is written here. I want to type 3. Fine. Now next is E2. We'll go to E1 later. Let's finish E2. E2 are called as external type 2 LSA. 2 is default. What does E represents here? It means type 5. Because type 5 LSA is what called as external autonomous system, external LSA, isn't it? So type 5 advertisement only will make router to show E2. The type 5, if you tune as E1, then it will show you E1. Metric type is the command. When I do the lab, I'll show you. So what I'm trying to show here, E2 means other autonomous system routes coming inside OSPF without path cost getting incremented in the path. E1 is path cost added like this. You see here. You might have seen this in the previous class as well. Now, let's say the external network is A dot B dot C dot D. This A dot B dot C dot D is redistributed into OSPF. For example, this is EIGRP. So I go to router 1 and say router OSPF redistribute EIGRP autonomous system 10 followed by metric 1789. So this is one line command. I typed redistribute EIGRP 10 metric blah blah. I redistributed. Now R3 will learn A dot B dot C dot D with the metric of 1789, sorry 85. R4 will also learn the same. R5 will also learn the same. You see, there is no change in the metric. So that is the metric that is given as a seed metric. Seed, why they use the word keyword, why they use this word seed here? When you put the seed in the soil, the seed will react with the mud and water. It will start growing like a plumule radical, and then it will become a plant, and then plant will become a bigger plant. A bigger plant will become a tree. That's why they say it is seed metric, meaning if you give 1785, then the path cost 10 will get added, then it will become 1795, 85 will become 95, and here again another 10 will be added, 1805, again another 10 will be added, 1815. So it keeps growing. Only if you make it as E1. You see, after this metric command, there is another metric type 1. All are single line. I'll do and show you. When you say type 1, the default is type 2. Type 2, it's like a seed which never grows. The seed never grows. That is type 2. By default, the seed never grows. Please understand, this is one important interview question. By default, when you redistribute, will the metric grow? No. Because by default, it is type E2. E2 means don't add the path cost. Do not add the path cost. E1, add the path cost. Right. Now, one important question, why do we need to change to E1? In what situation, in what scenario, we may need to change it? You see, if I will have another autonomous system, or if I will have another connection to the same autonomous system, let's take same autonomous system. Assume you don't have this link. You have a switch. Assume you don't have this link. So I have redistributed here as well as here. Now 2 ASBR we have. Someone here will simply go like this. But someone here will go easily like this because this is ASBR. If I go through this ASBR, additionally 10 metric is added. So when you make E1, this path cost gets calculated. The routers will compare the path cost, and one with the low path cost will be considered as the best path. But if you don't have more than one ASBR, when we don't have more than one ASBR, there is no need to increment the path cost. There is no need to calculate the path cost. Let's maintain the seed metric. No need to increase the seed metric. Maintain the same metric. What is periodically? Nothing periodically here. Whenever LSA advertises, you know about LSA. LSA will be advertised whenever there is a change in the topology. That is one reason when LSA will go shoot out. Secondly, whenever there is the periodic time, 30 minutes. Every 30 minutes, long back, you remember the first chapter. Every 30 minutes, whether there is a change or not, the link state advertisement will be sent periodically. You should not mix with the cost here. Sorry, what did you say? Yeah, something with cost you said. Yeah, cost. Don't get confused with both. There is no cost advertised. There is cost along with link status. So you should not see only cost separately. You see, if this link is there, then link state advertisement will keep coming from this link whenever there is a change. But when the link breaks, automatically the routers know that I should go this way. You don't need to send periodically. Whenever the change happens, immediately they shoot out that LSA change notification. Others will adjust accordingly. Yes, there is DBD synchronization every 30 minutes, but that is not anyway connected to this scenario that we are talking about, Balaji. Hmm. In what way it is connected? I don't understand. See, links and advertisements are sent only when there is a change. If not, it will be sent only every 30 minutes. And, Jana and Bala, please ask me a question if you have on this E1, E2. The reference bandwidth. Bala, you see, there is a formula to calculate the cost in OSPF. The formula is like this: 100 divided by the bandwidth on that link. 100 divided by bandwidth on the link. And it is not in kbps or gbps, it is mbps. 100, from where they got this 100? Just for reference they kept it, so no need to do much research on that. When I was a small boy, we used to talk like this: is your house bigger than LIC building? See, from where the LIC building comes. On those days in Tamil Nadu, Chennai, LIC building is the toppest one, the highest one. Because on those days, no permissions were granted to build bigger than that. Now a lot of buildings are there bigger than that building. Every street has got now bigger than that building. But those days when I was a small boy, we used to talk like that. Then my friend will say, no, not that tall. My house is half of that LIC building. Something like that. So we use that as a reference to make others understand how big is my house. Because everyone knows that LIC building, how tall it is in Tamil Nadu. So they used to refer that my house is half the size of LIC building. My house is quarter the size of LIC building. 1/4 of the LIC building. So others can imagine now how big is his houses. That is what called as reference, referring to something. Here, 100 is used as a reference bandwidth. Like LIC building on those days was the biggest building. When OSPF was designed, 100 meg was the maximum bandwidth that world can see. 100 is the biggest. Very rarely 100. And it is said that there is no chance of 100 on those days. No one imagined that we will reach 100 Mbps. But now we have 10 Gbps, 1 TB and all. But on those days, today we have 100 GB port, QSFP plus ports. On those days, we used to have network in kbps. And we did not realize that very soon we will be moving to Mbps, Gbps. So as the upper limit, as a reference, they used 100 meg. But this formula with 100 meg is not okay for today's scenario. See, when you have fast Ethernet and Ethernet, fast Ethernet works in 100 meg speed. Ethernet works in 10 meg speed. Now this formula is okay to use. 100 divided by, what is the bandwidth on this link fast Ethernet? 100. 100. Cost is 1. So here the cost is 1. In the below link, it is 100 divided by 10. What is the cost? 10. So OSPF will say, I will pick this path because this path has got low cost. More bandwidth, low cost. You understood this part? Okay. Now, let's say both are not, or one be 100 meg and the other one is 1000 meg. Gig Ethernet, 1000 meg. When you have 1000 meg, you see the denominator is 1000 now. But the numerator is still 100 in the formula. If you divide this, it will come in some fraction number. But there is no fraction number in metric. So it will be sealed to 1. So what will be the metric here? The cost here 1. This also 1, this also 1. See? This is not right, no? This is not fair. How can the cost be same for fast Ethernet and gig Ethernet? But the problem is your formula is the problem. Because in your formula, you are referring to only LIC building. But you're comparing Trump building to LIC building. Or you're comparing this. So you are trying to explain someone about the height of Burj Khalifa with the LIC building in Chennai. So if you say someone who have never seen Burj Khalifa, if you tell someone that the building is very tall, Burj Khalifa is tall, then he will ask, is it tall like LIC building? He will say, yes, yes, yes. Then he thinks that Burj Khalifa is only LIC building height. That is what happened here. One same cost. For LIC building also one, for Burj Khalifa also one. So instead, you should have compared with something else. Maybe the Mount Himalaya. So what I'm trying to say is you need to change this numerator by using this command, auto cost reference bandwidth. See, in OSPF, cost is calculated automatically by referring the bandwidth, by using the bandwidth on the link. For that only, you're going to change this value. So put this command under OSPF, router auto cost reference bandwidth, and then give Himalayan, instead of 100, give 10,000. Now, if you change it to 10,000, this becomes 10, and this becomes 100. The bandwidth on the fast Ethernet port is 100. So 100 you cut this 20, then you get 100. So here it is 100. Here it is 10. Which one is cheaper? Going via gig Ethernet is cheaper. What I'm trying to show you here is only when you change the numerator of this formula by using this command, your OSPF will have visibility to the bandwidth when you have more than 1 meg, 100 meg. When you have more than 100 meg links, you must change the numerator value of this formula by using auto cost reference bandwidth. Did you understand? Bala, understood this? Okay. I did not change cost. When did I change cost? Mhm. Reference bandwidth we changed. Okay, tell me. Hmm. Yeah, you have to set the numerator accordingly. Big number, more zeros. And if you are doing this in one router, you have to do it on every router. Don't forget. You must do it on every OSPF router. Right. Now, the summarization is done in two places. One is type 3. Where is type 3 originating? ABR. So that is called as ABR summarization. For all the networks that are coming from area 1, we do summarization here so that it will be summarized and sent. So you summarize. By doing so, you minimize the routing table entries on the receiving router. Not only that, if any change happens in one of the subnet, it is localized. It will not be shooted. It will not be flooded, disturbing other area members. So it is localized. The impact is localized whenever the topology change occurs. Thirdly, you are reducing the number of type 3 LSAs, which is flooding. If you don't do summarization, more LSA type 3. When you do summarization, you are reducing the number of type 3 LSA. Not only that, you can also reduce type 5 LSA if you will do summarization on ASBR. In this picture, you don't have ASBR, but see this picture, you have an ASBR. Type 5 originates from ASBR, and you want to summarize this 32 to 64. 32 to 64 is totally 32 subnets. 32, 33, 34, 35, 36. If you keep counting, it will be 33, including this 32 number, it will be 33. Instead of sending 33 type 5 LSAs, instead of sending 33 line of updates, I'm going to simply send one type 5 after summarizing. Further, the command is this: summary address. You go under OSPF and say summary address starting from this, and then ending is 63, but where do you see? You see here. You are mentioning that here. 255 minus 32. 255 minus 32 is 224 or 256. 256 minus 32. 2 to the power of 8 is what? 256. 256 minus 32. 224. Now, by writing 224, you are saying from 32 to next 32. 33, 34, 35, 36. It will go up to 63. After 32, next 32, which will go up to 63. All right, so you don't need to mention 63 just by putting the right summary here, sorry, the subnet here. The router will know that I need to summarize up to 63, starting from 62. Sorry, 32. Starting from 32 up to 63, I have to summarize. Remember, the command is what? Summary address. So type 5 LSA will now be reduced. Likewise, type 3 can also be reduced if you do summarization on ABR. For example, you see here. You have ABR and you got these areas, these networks in area 1. And you want to summarize in 2 lines. You don't want to summarize in 1 line, you want to summarize in 2 lines. Why? From 8 to 15, you want to do one summarization. From 16 to 19, you want to do another summarization. Again, the same story. Summarize in ABR. These are advertised in many routers inside area 1. And it is coming to router 3 as type 2 and type 1. Now, when you do summarization, you are reducing the amount of type 3 going out. Tell me. That I'll do. Wait, that I'll do. Wait, I'm coming. You want to summarize from 8.0 to 15.0. So I say starting from 8 up to 16. So 9, 10, 11, 12, 13, 14, 15. How many is there? Another 8 or 7. Sorry, another 7. Another 7, isn't it? Leave 8. After 8, count up to 15. How many you have? 7. 9, 10, 11, 12, 13, 14, 15. How many you have? 7, right? So 255 minus 7 is what? So now router understands that I need to summarize 8 to 15 as 8.0 slash, what is the mask here? 8 plus 8 plus 5. 5. 16 plus 5 is 21, slash 21. Here it is slash 24. You are summarizing to slash 21. Okay, now this is how you put the command like this. Area 1 network, starting from 32, I'm summarizing. So 255 minus 31, which is 224. Likewise, area 1 network from 96 to another 31. So I put this. So you have to say the area ID correctly. You see, 96 to 127 is in area 0. So I have to say area 0, 96. 32 to 60. So from which network this route coming? That is what the area you have to mention. You should not focus on to which area it is going. You should not see to which area it is going. From area 1 it is coming. From 32 to 63 I need to summarize. So you should say area 1. It is actually going to area 0. That doesn't matter for you. Area 1 range. See, this is not summary address command. Summary address command is only for ASBR. ABR summarization command is area ID range. Don't forget. Okay, tell me. Question. What is your question, Bala? A couple of examples. There is no more example other than this. You should ask question. You should not simply say a couple of examples. What better example I can give other than this page and this page? Hmm, hmm. Wait, you have a network. You need to do this lab, okay, later. Whatever I am drawing now. 10.1.0.0, 10.2.0.0, 10.3.0.0 goes like that up to 10.30.0.0. Let's say starting from 10.0.0.0. This is slash 16. All are slash 16. Now I want to summarize this. Simple summarization is, let's say this belongs to area 10 and this is area 0. So I need to say router OSPF area, very good, 10, range 10.0.0.0, 255.0.0.0. This is simple summarization. Not only up to 30, even if you have up to 255, it will be summarized to 10.0.0.0 slash 8. So it will go like this 10.0.0.0 slash 8. If you simply put like this. But if you want to be more granular, you can say like this 255 starting from 0, okay, second octet, starting from 0 up to 30. So 255 minus 30 is not a block size. You subtract 30 and see what do you get? 2. Do you have 225? You have only 224. When you count the bits, first 3 bits, 224. After that, 260. Yeah, that is how you can increment. So what you can do is you can say 224 zeros. So this will be not slash 8, this will be slash 11. This is more accurate summarization. You got it? You need to try this. Okay. Now, yeah, you see, that is how the planning need to be done proper. Here, starting from 0 till 31 is summarized here. Till 31. Wait. Let me finish. Hold on, please. Sorry to interrupt. But your question was, what if there is another area with 10.31.0.0? Are we not summarizing for that network and sending? Of course, yes. You are summarizing for that network. So when a packet arrives in this direction from somewhere here, from this router, which wants to go to 10.31, it will be sent here, which is not here. So you should not use this if you are doing summarization to 224. Or what you can do is you can summarize up to 16 by making it as 260 and leave the balance to be sent without summarization. Okay, now you put your question, Jana. That's what I did now. Correct. Yes. You can separate it like that. Small pieces. So in case if 10.31 is used somewhere else, then don't do /11, do /12. And for the rest of the network, leave it default. The detailed routes will go. If you say /12, only 0 to 15 will be summarized. All the rest will be sent without summarization. And what you can do is after 15, you can say starting from 16, maybe another summarization /248. So, sorry, I made a mistake here. It's not 260. No, what I made is, it's not 260, 160, 224, 228. Instead of 228, I wrote 260, 228. So 240, right, 240. 224 plus 16, that is right, 240. So you need to do like that, 240, and then for the remaining, you can have 248 summarization, 248 for the balance. Like this, let me do it. Let me do it. Bala is thinking too much. Still, he has not got the understanding. Am I right, Bala? 10.1.0.0/16. If you are quiet, then I understand that you did not understand. If you understand, you tell me understood. You understood, we can go next. 10.4.0/16. Writing like this up to 30 is very terrible punishment for me. So let me put dot 10.15.0.0, 10.16.0.0, 10 dot 10 dot, let's say 31.0.0. If you have 31 here, no problem. What if I have 29? And then how we will do summarization. So what you can do is, you can do summarization up to here. How? You can say area 10, range 10.0.0.0, 255 dot 255 minus 15. What is that? 240, yeah? Yes, 240. So up to 15 will be summarized. Next, area 10, range again, 10.16.0.0. You're starting from 16. And what you can do is, you can go up to 8, next 8, means 17, 18, 19, 20, 21, 22, 23, 24, up to 10.24.0.0, which will be 255 dot 255 minus 8 is what? Actually, um, the block size is 7. So 255 minus 7 is what? 248. So this is going to summarize up to 24. So balance you just leave 25, 26, 27, 28, 29. This 5 thing will be sent without summarization. Or you can do another summarization for this, like this. Area 10 range, starting from 10.25.0.0, 255 dot minus 3, 255 minus 3, 252. So starting from 25, 26, 27, 28, up to 28 you are summarizing. 29 will be sent without summarizing. Bala, you understood this? Back up. Very well. No. Ah, right. Very. See, this is something which we do on the edge route. If you want to advertise a default route, first you need to write one default route towards your ISP, IP, route, any network, any subnet mask, send it to ISP 192.1.1.1. After you write this, under OSPF you go and say default information originate. When you say that, OSPF will advertise a default route to every router in all area. You may have many areas. Every router will get default route. So you don't need an E2 or E1. Why you need? Why you should redistribute and make your CPU waste? Just inject on default route. Did you understand? This is your ISP. Instead of taking all 1,000 routes from ISP, you just have a default route on R1 towards ISP. This is static default route. And inside your network, you want the default route to be propagated using OSPF. For that, you put this command default information originate so that every router will dynamically write a default route pointing towards this R1. Did you understand? Now, in case if you don't have a default route, static default route, if I don't have this static default route, and still you want to generate and send a default route to everyone, then you need to use the keyword always. You need to use the keyword always if you don't have default route. You need to try all this thing in the lab. See, here is the example. There is a static route, default route written on R1 pointing towards this, and there is static route written on R2 pointing towards this. So I can simply say default information originate, enough. You don't need to use the keyword always. And if you want to prefer this one primary, then you give low cost asymmetric. 100 is second preference, 10 is low preference. So router 1 will inject a default route with cost of 10. Router 2 will inject the default route with cost of 100. Which one everyone will follow? 10 they will follow. If this fails, then automatically they will fall to this one. Did you understand this example? Take time. No problem. Take your time. Understand well. Oh no. And then it also explains the default information originate command. Did you understand that part also? Right.